Okay, we're going to work our way through the Reteaching 6.6 Part 2 that deals with kites. And if you did the PowerPoint like you should and listen to the explanation video, you should understand that working with kites is all about triangles. The kite is divided into different types of triangles based on whether one or two diagonals are in the picture. So here I have the two diagonals, and I have to remember that right there is a 90-degree angle. That's the secret to this problem. If this is a 90, I know this one is I know this one is 18, then I will add those two angles up and subtract that from 180. That's how I would find this missing angle 1. Now I have to remember what we said in our PowerPoints, that these two triangles are going to be congruent right triangles because of hypotenuse leg. So angle 1 and angle 2 are corresponding angles, corresponding parts, so they are going to be congruent to each other. All right, look at number 15. I have the two diagonals again. I know that angle 2 is the right angle, because that's where the two diagonals are perpendicular. I know one angle is 48, I know one angle is 90. So if I add those up and subtract, I get the missing angle here to be 42 degrees. You have to see that these two triangles are congruent right triangles. I said that in the PowerPoint. Both diagonals gives you two different pairs of congruent right triangles. So the corresponding part to this angle 3 would be that 48 degrees there. All right, in number 16, I have isosceles triangles because I only have one diagonal drawn in, the one that passes from one congruent angle to the other. This diagonal does not bisect, but it makes two isosceles triangles. In this situation, angle 1 is a base angle. So 70 and angle 1 have to be congruent to each other. So angle 1 is going to be 70 degrees. If I know angle 1 and angle 70 degrees are my base angles, they have a sum of 140. So that leaves my vertex angle at angle 4 being at 4 being 40 degrees. Over here on this side, I have isosceles triangles also, but I have different base measurements. Angle 2 is the base angle, so it measures 54. I will add up my two base angles and get 108. If I subtract that from 180, I get my vertex angle at 3 has to be 72 degrees. I noticed when I was working through this that I left off the measure of angle 5, so you'll need to add that. And when you turn in your reteaching and you don't have that there, then I'll know that you didn't pay attention to this video. Again, whenever you have both diagonals drawn in, you have a 90-degree angle. So I'll put that down immediately. Angle 2 is not what I solved for first. I actually solved for angle 3 first. Remember, this is a 90, so 180 take away 55 plus 90. So I went 90 plus 55, and that gave me angle 3 to be 35 degrees. Now, y'all, here are your two right isosceles triangles. These, congruent right triangles, not isosceles. These are congruent right triangles because of hypotenuse leg. So 3 and 2 are corresponding to each other. 3 and 2 are corresponding. So after I found 3, I can find 2. So 2 is going to be 35 degrees. Now, here are my other two congruent right triangles, corresponding parts. So angle 5 is actually 62 degrees. And then remember, if you know that this is 90 right in here, and you know this angle is 62 degrees, you can add those up and subtract from 180 and get your missing angle 4 to be 28. So you're kind of skipping around in the order there. Okay, lastly, we have a kite that we are trying to solve for the variables in each kite. Now, in this situation, we only have the variable x, so that makes it nice. What's going on here is that this angle right here is a decoy. That angle doesn't have anything to do with the problem. It's a decoy. What's important is that right here I have a 90. Here's my angle 4x. Here's my angle 2x plus 6. I'm going to use the notion that 3 angles in a triangle add up to be 180. Excuse me. 3 angles in a triangle add up to be 180. So 90 plus 4x plus 2x plus 6 equals 180. I add up my x's and get 6x. I add up my 90 and 6 and get 96. When I subtract 96, I get 84. And when I divide by 6, I will get 14. So in this case, I'm only solving for x using that lower triangle on the right there to solve for x. All right, let's turn around and look at the back side. On the back side, these problems are a little more complicated because I have an x and a y involved in them. In number 20, I'm ignoring this 2y for the start of the problem. I have a 38, I have a 17x plus 1, and I have 3x plus 1. I notice that those are 3 angles inside a triangle, so their sum has to be 180. So when I add up my x's, I get 30x. When I add up my numerals there, I get 40, subtract 40, and get 140. X has to be 7. So now I know that x is 7. Now here's the important thing that I've got to know from today. These 2 angles are congruent because this diagonal makes 2 congruent triangles by side, side, side. These angles are corresponding and congruent. So I will set 2y equal to 17x plus 1. But remember, I know that x is 7. 7 times 17 is 119 plus 1. So 2y is really equal to 120. So that would make y equal to 60. That one's fairly simple, I think. And the next one, it's a little more complicated. Because when I initially worked this, I thought that was an x there. And then I went back and looked at it and I'm like, no, that's a y. So here I have x's in my expressions. Here I have y's in my expression. So initially I looked at my 2 triangles and I realized that these 2 triangles are congruent to each other by side, side, side. These are those angles that are equal to each other in measure, so I set them equal, or they're corresponding and congruent angles. So 3x minus 5 is equal to 2x plus 10. I subtracted the x and added the 5. So now x is 15. If I think about this, that makes this angle right here at this corner 40, because 2 times 15 would be 30 plus 10. This angle right here is 40. This angle is 6y plus 8. And remember, these 2 triangles are congruent to each other, so I can move this 7y to this, 27y to that position. So now I have a triangle with 3 angles in it. The sum of the 3 angles is equal to 180. So 40 plus 27y plus 6y plus 8 equals 180. 40. This one's 27y. This one's 6y plus 8. That gives me 33y plus 48. 33y is equal to 132. So y would be 4. And it's not that complicated. You just have to look at the picture and think about what type of triangle situation do you have. Kites are all about triangles. All right, the next part says determine whether each segment is true or false and justify your response. So question 22 says, are all kites quadrilaterals? And we're going to say yes, because all kites have 4 sides. That's all it takes to be a quadrilateral, is to have 4 sides. It says, is a kite a parallelogram? And we're going to have to say false, because remember, in a parallelogram, opposite sides should be congruent. But in a kite, opposite sides are not congruent. Okay, so a parallelogram, is a kite a parallelogram? And it says no, because to be a parallelogram, opposite sides need to be congruent. It says, can a kite have congruent diagonals? Now, when we think about that, we might think about a rectangle, but here's the difference between the diagonals of a kite and a rectangle. This is true as long as only one of the diagonals is bisecting the other. If you have 2 diagonals that are congruent and they bisect each other, that makes a rectangle. So just make sure that if your 2 diagonals are congruent, only one is bisecting the other. And then it says both diagonals bisect all the vertices. And we know that that is false. Only one of the diagonals, this one right here, is the one that does the bisecting. This diagonal does not. I have on here to just stop at this point. When we get back together on Monday, we'll finish out this reteaching and then do a practice. Thanks.